Okay, so this is section 2.2. This section is a little bit long. I'm a little afraid I may go over the 15 minutes that YouTube will permit. So if I do, I'll put the second half in a second video, so just know that that could happen. In 2.2, we're going to talk about linear equations. All linear equations is a function, you saw the word function, meaning it passes the vertical line test, whose graph is a line. So all of these will be lines. Now, you had these in Algebra 1, and then I know last year in geometry, the teachers went back over these quite a bit as well, so I think you'll be familiar with some of what we talk about today. So the first thing we're going to talk about is slope. Now here I have the textbook definition, the ratio of vertical change to the corresponding horizontal change. The bottom line is the slope is how steep your line is. That's what it is. Here's how you find it. You take your vertical change, which is your rise, over your horizontal change, which is your run. You've probably heard the rise over run before. If you need it as an equation, here's your equation. y2 minus y1 over x2 minus x1. Y is on top, okay? So let's find slope of a couple of lines. So here's my x, here's my y on 2 points. Okay, now here's what they want us to do. They want us to find the slope of a line passing through 3, 2, and negative 9, 6. So I'm going to plug it into my formula for slope. And basically, it would be a good thing if I actually put the equation here and go through and calculate my slope. So y2, I'm going to make this 0.1, this 0.2. So y2 minus y1 over x2 minus x1. So 4 over negative 12, which reduces to negative 1/3. Now you need to make sure to be consistent on what is your first point and what is your second point, but the order doesn't matter. As long as both of these are 1s or both of them are 2s, and same thing here, that's fine. Okay, so let's do one more. The slope of a line passing through 0, 0 and 2, 6. So here's our equation. Hopefully you have it in your head. I won't give this to you on a test, so make sure you have it in your head. So y2 minus y1 over x2 minus x1. So 6 over 2 is 3, like 3 over 1, but we just write it as 3. Okay, now when we're talking about linear equations, there are 3 forms you might see them in. You might see them in point-slope form. Here's point-slope form. Now in this form, it's called point-slope form because it has a point in it. Here's your point, there's your x1 and y1, and it's got slope, which is represented typically as the m. Now in your equation, your y and your x here stay as a y and an x. Okay, your second form is called standard form. You will see things written in standard form quite a lot, but you don't typically find equations in standard form. You change it into one of the other 2 forms. And the last form is slope-intercept, also known as y equals mx plus b. You've probably seen this before. In y equals mx plus b, m is your slope, and b is your y-intercept. I like slope-intercept form. It's my preference over the other 2, but you do need to be able to use the other ones. So since I put point-slope form first, let's start with point-slope form. So actually, let's change this. Let's start with point-slope form, but we'll end up with it in y equals mx plus b. Okay, now here's your point-slope form. So what they ask us to do is find the equation with a slope of negative 1/2, so I'm going to plug that in right there, and passing through this point, 8, -1. So that's my point in here. It's the x1, y1. So let me plug that stuff in. Now I'm going to put +1 here because I've got a double negative, minus a -1. Okay, here's my slope, -8. And I'll go through and I will simplify. Now, I simplified in point slope form. I distributed out my -1/2. They want me to end up in y equals mx plus b, so let me go one extra step to do that. So y equals -1/2 x plus 3. So you start in point slope form to see how you can end up in y equals mx plus b slope intercept. Now I want us to do this one a little bit differently. I want us to never use point slope form on this one. I want us to always stay in y equals mx plus b. Okay, so we're finding the linear equation passing through 1, 5, and 4, -1. This time they did not give us our slope. However, we know how to find it. y2 minus y1 over x2 minus x1. So -6 over 3 is -2. So there's my slope. Now, I'm going to start in y equals mx plus b form this time. We're going to do it a little bit different way than we did a second ago. So here's my m. Now, if I want to find my b, which is my y-intercept, I'm just going to pick one of these points and plug it in temporarily for the x and the y. So plug in here and plug in here. So when I move my 2 over, b is 7. So y equals -2x plus 7. Now, we could have done this one with point slope form once we got the slope and used that point the same way we did a minute ago. This is just a second way to do it, to temporarily plug in one of the points, then put your x and your y back. Either one is fine. It'll get you the same answer. Okay, now looking at this, you'll notice that you are in standard form. What I want us to do is find the slope. Now, standard form is a pointless form because it does not tell you either slope or y-intercept or a point. It doesn't really tell you anything. So what we need to do is get this in y equals mx plus b so that we know what the slope is. So I'm going to do that. I'm going to move my 4x over, so I'm going to subtract it to the other side of the equal sign and divide by my 3. Get that y by itself. So y equals -4/3 x plus 2 1/3. So my slope is my m here. This is my y-intercept. But my slope's what they asked me for, so it's -4/3. Okay, so let's do one more of these. Now, same thing, this is in standard form, so I need to get it in y equals mx plus b so that I will know what my slope is. So I'm going to move my 3x over. So I subtracted it to the other side of the equal sign. And there's my slope. Now my y-intercept's -10. They only asked me about the slope. Okay, now we're going to do two other things in this section. We're going to talk about parallel and perpendicular lines, and we're going to talk about graphing. So we're going to start with perpendicular. Now, if you're talking about perpendicular lines, sometimes you'll see them use this symbol right here. See how those lines are perpendicular? It means they're at 90-degree angles to each other. If you've got one of the lines, the perpendicular line's slope is the opposite reciprocal. Now, most of the time, its y-intercept is also different. So typically it has a different y-intercept. Usually a different y-intercept. Okay, if you're talking about parallel lines, and this is the symbol that's usually used for them, the slope is the same, and it has a different y-intercept. Okay, so here's what we want to do. We want to find a line that's perpendicular to y equals 3/4 x plus 2 and goes through the point 0, 4. Okay, now let's go and think y equals, well, let's use point slope on this one. So let me write out my point slope form. Okay, so if I'm talking about my slope, here's the slope of the line they gave me. It's 3/4. A perpendicular line has the opposite reciprocal slope. So opposite, it's going to be negative. Reciprocal, I'm going to flip it. And then they gave me a point. So I know my x and I know my y. So let me simplify this down. So when I distribute out the -4/3 x, -4/3 or anything times 0 is 0, so I don't have to write it. And then I'll bring my 4 over to get it in y equals mx plus b. So there is my perpendicular line. Okay, let's do one more of those. Now we're going to do another perpendicular. So similar line. Now my slope, let me go ahead and write out my point slope. Okay, so my slope has to be opposite reciprocal, and I've got my point. Okay, so let me go through and simplify this down. So I'm going to have to distribute out my 4/3, so -4/3 x. Okay, and let me do this on the side of my paper. -4/3 times a -6. The 3 and the 6 reduce, so I'll have positive, 2 negatives make a positive, 8. And then bring that 1 over. So y equals -4/3 x plus 9. Now, we have a little bit more that we need to do, but I'm going to stop right here and put the graphing lines in a separate podcast because I'm getting pretty close to my time limit on here. So I will see you in a minute for graphing some lines.